Okay, so we're just going to look at how you solve trig equations, and we'll go through some basic ones in this video, and then in later videos we can look at some harder ones. So basically a trig equation will look something like this. You'll have a function of some kind equals a value on the other side. And what it's really asking is, where does this function pass through this value? So if we look on our graph, if I put in 0.5 and go across, like so, you can see it passes through in two places. Okay, so from a graph we could actually get our solutions, but clearly, sometimes they're not going to come out nicely like this, and we'll get some nasty answers. So we need to be able to solve it algebraically too. Now, the way to do it is to undo what's been done to the x. Now, the opposite of the sine function is inverse sine, so that means that x is going to be equal to inverse sine of 0.5. So we're kind of moving, if you like, the sign from one side to the other, or we're undoing the sign, if you like. So we're just doing a regular algebraic manipulation here. Now, when you work that out, you should find that that is 30 degrees. Now, that is our lowest positive value. So that's what we call our principal solution. Okay, so that's the first one. It's the lowest one. The second solution, your calculator won't show that. So you really have to have a good knowledge of these graphs. And if you ever look here, obviously from the graph, we know it's 150 degrees. But also we can work this out. We know that these graphs are symmetrical about their apex, about that highest point. And you can see here, if we go, say, 60 degrees that way, we get down to the 30, because you can see the line of symmetry is at 90. If we go 60 that way to that solution, that's good. If we go 60 that way, it will give us the next solution at 150. So we can use our knowledge of these graphs and the symmetry to actually find different solutions. So let's look at another example. So here, cosine x plus 1 equals 1. So again, if we just quickly sketch a line of 1 through our equation here, we should get a solution at 90 and a solution at 270. So let's have a look here. If I was going to solve that, I would want to take away the 1 from both sides first. Then we remove the cosine by doing the inverse of it. And that is actually 90 degrees. That gives us our first solution, which is great. That's our principal solution. So principal solution. And again, I'm just going to have a look at, say, this line of symmetry through 180. My principal solution is 90 degrees away from it that way. So if I go 90 degrees that way to 270, that does give me my second solution. So your knowledge, again, of these graphs, you can quickly sketch them, will help you solve them. More complicated one here, you can see there's been a couple of things done. So we've got to remove the -1 first. So 2 cos x will equal 1, then divide by 2, and therefore when we do the inverse cosine function of a half, we will get x is equal to 60 degrees. That will be our principal solution. Now we can verify that because we're looking for, where does this line pass through a value of 2? Well, there it is there at 60 degrees. And again, I'm going to look at my knowledge of the symmetry of these graphs. Well, there's an apex point there at 0. That's 60 degrees across from it. So if I go and find my next apex, which is way over here at 360, if I go back 60 degrees from that, that will get me to 300. And you'll see if I'd continued my line of 2 across, that would also have intercepted at 300. So that's my second solution. Okay. And last one here, this is if the tan graph, you can see that's actually been moved sideways 5 degrees. So here, if I was going to solve that one, I would do my inverse of tan. So like so, which means x minus 5 is 45 degrees. Therefore, x is going to be 50 degrees. And if we have a look here, if we go through our line, that is at 50 degrees. Now this repeats, tan repeats every 180 degrees. So remember, it has a period of 180 degrees. So that means the next one will probably be at 230. So let's verify that. If we come across here and come down, you can see there we are at 230 degrees. So again, 50 is our principal solution because it's the lowest positive value, and then we're using our knowledge of these graphs to work out multiple ones. Now there are general solutions which we will look at in a later video, which can save you having to try and visualize these graphs. But for now, we're just going to try and solve them by finding the principal solution and then either sketching or just using our knowledge of the graphs.